Testing 1, 2. I've got a green light back here, so I'm just going to start talking. Well, good evening. We got a lot of ground to cover, so I'm going to talk fast, you listen fast, and we'll dive right in. Welcome to In the Beginning, a biblical and scientific investigation of our past. Quick reminder who I am. My name is Joel Brown. This is my family. They're here tonight. My wife Erin, and all of our kids are here someplace. Some of them are back in the nursery. They've heard this a few times. We live right here in St. Louis, but I do travel and speak quite a bit as time allows, as opportunities allow. I do this purely for the fun of it. It's not, I say for the fun of it. I mean, I think it's very important, but there's no, it's not a job. It's just a mission. In my day job, I'm a high school science teacher. So spend lots and lots of time outside exploring nature and teaching high school students about how nature works. Before becoming a high school science teacher, I spent 10 years in scientific research, earning my master's degree and PhD, studying things like embryonic development. So that's a review for most of you, but just wanted to give everyone a little background there. I always like to start by talking about something that's happening in nature right now, because that's what I do for a living. What is this late summer plant? Do I have any takers? Yeah, this is goldenrod. There are about 23 species of goldenrod in Missouri alone. So it's a very diverse plant family. Its scientific name is solidago, which means to make whole. So it was used for some of its healing properties by Native Americans. It's apparently, I haven't tested this, it's a diuretic. I'll have to try that sometime. Now, have you ever heard of hay fever? Sure. Now, this plant, which is common right now and will be the rest of September, this is all over. You're going to start to see it covering any open field. This plant is often blamed for hay fever, pollen allergies. But it's not his fault. It is actually the fault of his little brother. Now, here's how you can know. See how bright those flowers are? A plant with bright flowers like this is not wind pollinated. It's pollinated by bees. That's why it has bright flowers. It has sticky pollen, not wind-driven pollen. Plants that are wind pollinated don't have bright flowers because they don't need to attract pollinators because the wind is doing the work. So the hay fever is actually the result of this guy, which grows in those open fields right alongside goldenrod. It's ragweed. And it does not have bright flowers. It is wind pollinated, and it causes all those allergies. So don't blame goldenrod. So we're asking a simple question. Where did all of this incredible stuff in creation come from? From the giant nebulae and galaxies and stars all the way down to the tiny stuff, the DNA, the bacteria, the molecular motors, and yes, the goldenrod. Where did it all come from? Well, if you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words, in the beginning, God created. And it's just as simple as that. We've been calling this the in the beginning God, or the biblical worldview. That's how I look at the world. We think of a worldview as a pair of glasses, the lenses or the beliefs through which we view the world around us and interpret it. In the biblical worldview, we have two core beliefs. We see amazing design, we conclude there must be an amazing designer. Here are my two core beliefs. I believe there is a God. I believe the Bible is God's word. But there's another idea out there. And we're contrasting this called, in the beginning, goo. Straight from Star Trek, from last week. This is the evolutionary worldview, and you're going to start seeing this everywhere. You keep your eyes out for it. Just the other day, I found it. 5 goo. Driving down somewhere else. Goo. It's everywhere. So in the evolutionary worldview, they see the same stuff, the same amazing design, and it is amazing to everybody. But they come to a different conclusion. They say it must have come about by time and chance. One core belief that they're using to make this conclusion, that is materialism. Or, as I like to put it, 3 simple words: no God allowed. That's what materialism means. Okay, so if you have these 2 different worldviews, you're going to come to a different picture of what the origin, in the beginning, looks like. In the biblical worldview, we would say about 6,000 years ago, God created everything. About 4,400 years ago, there was a giant flood. 2,000 years ago, Jesus came to earth, and here we are today waiting for him to come back. In the evolutionary worldview, they would say 14 billion years ago, there was the Big Bang. About 4.6 billion years ago, the earth formed. 3 billion years ago, life formed on planet Earth. And then about 3 million years ago was those first steps in the origin of man. Important point, can't be emphasized enough. Things that are different are not the same. This ain't rocket science. But it is a problem because they are different. Now, the problem is, usually when people find the difference between these 2 worldviews, which one do they try to fix? They try to fix the biblical worldview. Something must be wrong with the Bible. Now, I'm not going to try to prove the biblical worldview to you this series, in these 5 weeks. That's not my goal. You will see incredible evidence that points to a creator, but I cannot prove it to you in a test tube. It is inherently faith-based, and don't ever be ashamed of that. However, what you will see is that the evolutionary worldview, which is sold as fact, is also faith-based. Don't take my word for it. You will see it for yourself. And I'm using faith in its simplest form. I'm not using it in a religious sense. I'm just using it to say something that you believe which cannot be absolutely proven. The evolutionary worldview is a belief. You'll see that as we go. So we're looking at the 3 pillars of the evolutionary worldview: cosmic evolution, the origin of the universe, the origin of life, that's organic evolution, and the origin of you, Darwinian evolution. Tonight, we're looking at the first of these 3, cosmic evolution, in part number 2, to infinity and beyond. We're going to start with just an exploration of the universe with no worldview attached. So if you're an atheist in here, you're going to love it. If you're a Christian in here, you're going to love it, because we're just talking science with no worldview attached. Then we'll introduce the worldview halfway through. I want to take you on a journey. In 1977, NASA launched this space probe, Voyager 1, and it starts sailing through space. It passes this planet, Jupiter. Continues sailing through space. It passes this planet, Saturn. Keeps going and keeps going. Once something is moving in space, it doesn't stop. It just keeps going. On February 14th, 1990, before Voyager 1 left our solar system, it turned around. They turned it around, and they took this epic image. Look very closely. Do you see that? Let me zoom in on it. Do you see that? Do you have any idea what that pale blue dot might be? This is planet Earth. Planet Earth from 3.7 billion miles away. This is the furthest picture of Earth that has ever been taken. Well, raise your hand if you were here, if you were alive in 1990. You are in that picture. If you look really closely, you might. Okay, good. All right, this is a very famous picture, and the point is simply this: the Earth is just a speck in a vast solar system, which is just a speck in a vast galaxy, which is just a speck in a vast universe. So let's explore. I always like to start out with a quiz. So tonight I'm going to ask some quiz questions about the universe. I'm looking for raised hands on this one. Raised hands if you know the answer to one of these questions. If you can answer this question, you will get a Milky Way candy bar. Question number 1. What is the name of the galaxy in which we live? If you can answer this, you will get a Milky Way candy bar. Yes, sir, in the back. The Milky Way galaxy. Let's give them a hand. Isn't it wild that our galaxy is named after a candy bar? Or maybe it's the other way around, I'm not sure. Okay, question number 2. In 1990, NASA put a telescope in orbit around Earth to study the universe. What was its name? I'm looking for a raised hand. Josh. The Hubble Space Telescope. You'll see more of this guy later. What do aliens do before they go to war? You don't count. You don't count. Yes. Oh, no, that's not what they do. No, you guys don't know this one? You didn't learn this in science class? No. Oh, all right. They plan it. Tough crowd, tough crowd. I get the Milky Way on that one. Number 4, in 2006, which planet lost its planetary status? Tressa. Pluto. Now, ultimately, you know what it boiled down to? Pluto was just too small. Now, ladies and gentlemen, this is called galactic bullying, and it needs to stop. There are some other details. In fact, this is a very controversial decision made by the International Astronomical Authorities. Many scientists still consider Pluto a planet, and I do too. Number 5, what celestial event happened on August 21st, 2017, and will happen again on April 8th, 2024? I'm looking for someone who has not raised their hand yet. Do you know, Catherine? Okay, that's partially correct. Not enough to get a Milky Way candy bar. A solar eclipse. Can anybody improve on? She said solar eclipse, which is also more correct. Can anyone improve on it? No? I'll go ahead and give it. This is a total solar eclipse. Solar eclipse is fairly common, but a total solar eclipse is pretty unusual. And this is a great place to start our exploration of the universe because it involves the 3 heavenly bodies we are most familiar with. Number 1, the Earth, the Moon, and the Sun. Now, a total solar eclipse, which you don't want to miss. The last one passed, the shadow passed right past St. Louis. You were not in the total shadow, though. So it's worth it to travel a little bit to get into the total shadow. So here's how the total solar eclipse works. You've got the Sun. The Earth is orbiting around the Sun. The Moon is orbiting around the Earth. It does that monthly. And so periodically, it passes directly between the Sun and the Earth, casting a shadow down onto the Earth. And when you are in that shadow, it is absolutely incredible. The Moon completely covers the Sun, but just barely. So you still see this like halo around the Sun. It's incredible. This was the August 21st, 2017 path. St. Louis really is in a unique, once in a millennium position where both of these, the next one coming in 24, are crossing right here in Missouri. That's crazy. Now, I will warn you though, this 2024 one, which is coming next year, you're going to hear like, oh, we get 99% coverage of the Sun. That sounds pretty good, right? It's worth it, if time allows, to travel a couple hours to get 100% coverage. We traveled from New York to Tennessee to see the last one, and it was worth every mile. This is my oldest, right here now, watching the total solar eclipse. There's my wife enjoying the total solar eclipse. Here's my daughter, Karis, enjoying the total solar eclipse. So it's fun for all ages, right? So these 3 objects, we're very familiar with them, but they are not alone in our solar system. I've got all 9, I'm including Pluto in this one, all 9 planets up here with a raised hand. Tell me the name of one of these planets, and this is not good for Milky Way, so don't get your hopes up. All right, yes? Which one is Earth? Okay, good. So tell me the number and the name. Number 3 is Earth. Very good. All right, we got 8 to go. Greg. Is Saturn. 6 is Saturn. Andrew. 1 is Jupiter. In the back. Okay, why did you say that? Because it's kind of a reddish color. So that's good reasoning, but that's not actually Mars. So if that one's not Mars and your reasoning is correct, which one is probably Mars? 8, yes. So you were thinking correctly, but this is actually Mars. This one's Venus. It has a very thick gas atmosphere, and so it has this bright yellowish color. What else? Yes, right back there. Which one? Number 1 is Jupiter. Number 1 is Jupiter. We'll see that one again shortly. 4, Neptune, the blue Neptune. Which ones didn't we get? Let's see. Closest one to the sun, Mercury. We got Mars. We didn't get Uranus. And this, number 9, is Pluto. I kept that one in place. All right, so these are the relative sizes of these planets, but here's the tricky thing. You can't ever see both the relative size and their relative position in the same image. There's no way to view that, so I'll demonstrate that here in a little bit. These are the relative sizes of the planets. Some amazing things on these planets. Here's a giant red spot on Jupiter. It has not always been there. They started describing this a couple hundred years ago. They started noticing it. Did you see it? If you look closely, it's actually moving. This is a video. It's actually moving. This red spot is the size of planet Earth. That's planet Earth in comparison. And it is a hurricane, that's what it is. Winds up to 400 miles per hour. Can you imagine what the building codes must be like on Jupiter? It's crazy. Here is Mars. The Grand Canyon. It's pretty cool, pretty big. Here's a canyon on Mars called the Valles Marineris, Mariner's Valley. It's that giant scratch right there. Here is what the United States looks like in comparison. That's the United States. That is one giant canyon. Here in this nice cross-sectional view, this giant thing right here is the Mariner's Valley on Mars. What do you think this little divot is in comparison? That's the Grand Canyon. That's what the Grand Canyon would look like in comparison, which is huge. I mean, I'm not putting the Grand Canyon down. It's impressive, but we got some other incredible things in our solar system. I like to appreciate this scale. So let's do a thought experiment, shall we? Here's what I want you to do. I want you to imagine, in order to see the scale of the solar system, I want you to imagine that the sun is actually a 10-foot wide ball. We're going to squish it down, shrink the whole solar system down, so the sun is a 10-foot wide ball. We're going to place that on top of the Washington Monument. Raise your hand if you have ever been to Washington, D.C. Good, that's a lot of you, so you might be able to appreciate some of the distances here. So now we've shrunk the whole solar system down so the sun is a 10-foot ball on the top of the Washington Monument. Where are the planets? Let's see. Here's Washington, D.C., aerial view. There's the Washington Monument. There's the Lincoln Memorial. There's the White House. There's the U.S. Capitol. Okay, let's start putting some orbits where these planets would be. Number 1, closest one is Mercury. It would be 411 feet away. Keep going, Venus, 776 feet away. And then, of course, Earth, here we are, 0.2 miles away, 1,000 feet away. And Earth would be the size of this. It's one of those shooter marbles, not the little marbles, but the larger marble. It'd be about an inch marble rolling around the streets of Washington, D.C., 1,000 feet away from the Washington Monument. We keep going from there. Mars would be 1,600 feet away. These are called the inner planets, and you'll see why they're called the inner planets, because now as we move beyond Mars, these are also all rocky. They're inner rocky planets. Jupiter would be 1 mile away, just approaching the Capitol. It'd be about the size of a basketball. It's the largest planet out there. About the size of a basketball near the Capitol, orbiting around. Now we have to review, and there's the sun on top of the Washington Monument. There's the Capitol, so there's Mercury, Venus, Earth, all about the size of marbles. Mars, Jupiter way down there. In order to see the next ones, we need to zoom out a little bit further. So that's what I've done here. This is the image I was just showing you. There's the Washington Monument in the middle. There's the outline of Washington, D.C. So we've zoomed out quite a bit. Those are the orbits that I just showed you. Mercury, Venus, Earth, Mars, and Jupiter. Let's see where the rest would be. Saturn would be 2 miles away. Uranus would be 3.91 miles away. Neptune would be 6 miles away. And let's not forget about Pluto, 8 miles away, the only planet with enough sense to live completely outside of Washington, D.C. Oh, where would Voyager 1 be? It's still out there. Once something is moving in space, it doesn't stop. It's still going. Where would Voyager 1 be? Voyager 1 would be 28 miles away. Still going. Pretty amazing. What's the take-home message here? The Earth is just a speck in a gigantic solar system. Is there anything else out there besides our solar system? I'm so glad you asked. Our solar system is just a speck inside of a gigantic galaxy. Now, this is called the Milky Way galaxy. This is just an impression of what we think our Milky Way galaxy looks like. Nobody has ever seen it from the outside. In order to get a picture like this, you would need a galactic selfie stick, and those don't exist. The scale of this is just beyond imagination. We'll never be outside our Milky Way galaxy. But let's get a picture of what that's going to look like. So, when you go outside at night and you look up at all the stars that are filling the sky, those stars, you might wonder, like, are those like part of our Milky Way galaxy? Are those stars outside of our Milky Way galaxy? How's that work? It's a good question. Those are all stars within our Milky Way galaxy, with some exceptions, which we'll get to. So these are our neighbors in our galaxy. But how close is the closest star? Good question. So let's go back to our analogy. Suppose that the sun was here in Washington, D.C., and it was a 10-foot ball. Where would the closest star be? How far away would the next nearest neighbor star be? You ready? We're talking like the sun, another sun. Where's the next sun? It would be 55,000 miles away. In our little model here. You know, in reality, it's much further. That's how close the next nearest neighbor is. It's crazy how large these distances are. This is the sun's nearest neighbor, Proxima Centauri. It's actually a star system of 3 stars. So let's take a tour of our galaxy. This is me striking my best squint through a telescope pose when I was a kid. Now, in order to do this, though, we're going to need a slightly more powerful telescope. So let me introduce you to the Hubble telescope. The Hubble telescope was launched in 1990. Hey, that's the same year that they took that picture. 1990, that was a good year. Anybody here born in 1990? Okay, too bad, right? So here's the shuttle that's carrying the telescope. This is the telescope actually in space in 2009. It's about the size of a school bus. It cost $4.7 billion, which just sounds like pocket change nowadays. Length is 43.5 feet, weighs 24,000 pounds, and it orbits 353 feet above the Earth, and it's whizzing through space. You know, anything orbiting up there is moving very fast, 17,000 miles per hour. Why put a telescope up in space? It's a good question. The light pollution down here, but there's something that even in the darkest corner of the Earth, it still has a disadvantage. It's because we have an atmosphere. The atmosphere distorts all the light coming in, so you're just not going to get great images. But if you put a telescope beyond the atmosphere, then whew, you can get incredible images. So they spent all this money, all this time, putting a telescope up in space, and there was a mistake. This is the images that they started getting back. It looks kind of blurry. It doesn't look like a $4.7 billion image, if you know what I mean. So it's kind of blurry, and they were like, what's wrong here? Well, they made a mistake when they were manufacturing the mirror. The telescopes work off of capturing light, and they use mirrors to concentrate that light. So they made a mistake when they were manufacturing this giant primary mirror. It's 94 inches across, so about 8 feet across, weighs 2,000 pounds. This is a picture of them actually manufacturing it and checking it and everything. Now, I know what you're thinking. You're thinking, that doesn't look like a mirror, that looks like glass. That's because they haven't put the coating on it yet. So first they grind that glass, make it just right, and then they'll coat it with a reflective. So they did all that and got blurry images. they had made a mistake when they were making the mirror, and here's how far off they were. The thickness was off. It was off by 1/50th the thickness of a piece of paper. Wow. I didn't even know paper had thickness, right? But their mirror was way off. It was off by 1/50th the thickness of a piece of paper. Now, here's what's incredible. They actually fixed it by sending another mission up there, repositioning, putting some extra secondary mirrors in there to correct for this aberration, and they started getting incredible pictures. So this was before, this is after, same galaxy after the repairs. Now we're getting closer to those $4.7 billion images, and ever since then we've just been getting stunning images from the Hubble Space Telescope. These are all images from around our Milky Way galaxy. The most beautiful things that you're going to find out there are the nebulae. These are exploded stars, beautiful clouds of gas. These are twin jet nebula, the ring nebula. Here's a star in the middle with a cloud around it. Absolutely incredible. However, all of these pictures are quickly going out of date because they just put another telescope up in space. On Christmas in 2021, they put the James Webb Space Telescope up in space. That's what it looks like. It's up there now. And it is capturing even more incredible images. Partly due to better sensors, improved sensors, but partly due to this monstrosity of a mirror that they have on this thing. Here's the mirror, the actual mirror for the James Webb Space Telescope. Here it is compared to the Hubble mirror. It's 24 feet. So you can capture that much more light. That allows you to see things that are very, very dim. Now they become visible. By comparison, now this is Hubble Space Telescope, pretty impressive image of one of the most famous nebulae out there. The James Webb Space Telescope, using some different instruments, also incredibly impressive images. So they're both neat, right? I mean, I'm not going to argue. The Hubble is still pretty cutting edge. So that's a tour of our galaxy. Is there anything outside of our galaxy? Now that might sound like a naive question, but you know, 100 years ago, this was a debated question. Is there anything outside of our galaxy, or is it just the stars and us and that's it, you know? So, well, Hubble can answer that for us. So here's an experiment that they did with Hubble. They took the Hubble Space Telescope and they stared at a speck in space, about the size of a grain of sand held at arm's length. That was the speck that they stared at. But they stared at it for 11.3 days. Why stare at it for 11.3 days? Because anything in that speck that was very faint, if you stare at it for 11.3 days, it's now going to be visible. That's what they did. Here is, you see that yellow box? That's the speck that they stared at. Do you see anything in that yellow box? It looks kind of empty, doesn't it? Okay. Here is what they saw when they stared at that yellow box. I haven't showed it yet. It's coming. For 11.3 days. You ready? Oh, no, sorry. Wrong animation. Okay. Here is what they saw. All of that in that little speck of space. An estimated 10,000 galaxies in one speck of space the size of a grain of sand. Absolutely incredible. Now, here are some, so in other words, yes, there are lots of things outside of our galaxy. Here are some of the other galaxies out there. The closer ones we can see and get quite nice pictures of. This is the Sombrero Galaxy, Pinwheel Galaxy, much like ours. This is what ours probably looks like. Absolutely incredible creation. And I know I said I was going to keep Worldview out of it, but I just got to insert something. The heavens declare the glory of God, and the firmament showeth his handiwork. I just can't help but be in awe when I see all this. When I consider the heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him? Amen. And they didn't have Hubble. So, where did this all come from? Now, if you're stuck with a worldview that says no God allowed, you have a lot of explaining to do. So let's dive in. Well, you probably know the next two words I'm going to say. Where did this all come from? According to the evolutionary worldview, it was the universe exploded out of nothingness about 13 billion years ago. Scientists call this violent beginning the Big Bang. In a single second, the universe grew from being smaller than an atom to being 20,000 light years wide. It is still expanding and may continue to do so forever. One thing I want you to know, you probably recognize this already. You always see these things in textbooks or on a YouTube video, a show, whatever. It's always stated as fact, right? Like, as if somebody was there recording it. All right? And of course it wasn't. This is all based on their beliefs, So let's see a little bit about what they say. 18 to 20 billion years ago, the number changes from time to time. In fact, this summer, it just doubled. Some scientists just doubled the age of the universe. All the matter in the universe was concentrated into one very dense, very hot region that may have been much smaller than a period on this page. For some unknown reason, this region exploded. This explosion is called the Big Bang. Think about what they're saying. Everything in this room, on this planet, in this solar system, in our galaxy, in our universe, was concentrated into a point smaller than a period on a page, and actually much smaller, as you're about to see. So let me give you a short 30-second summary of what the Big Bang says. All right, this is highly simplified but accurate. Okay? According to the Big Bang theory, everything started as this infinitesimally small point which expanded rapidly. As it expanded, it was a hot, dense plasma which was opaque. As it expanded, it began to cool off. When it cooled off, those electrons and protons started coming together and formed gas. Primarily hydrogen, a little bit of helium, and even less lithium. Those are the three elements they would say. And then over time, those gas started to clump together. And as they clumped together, they heated up and turned into stars. Those stars lived and died and exploded. When they exploded, they spewed their guts all over their environment. And in those guts was some heavier elements that were formed inside those stars. They formed more stars and that grew and exploded and spewed their guts all over. And then eventually there were enough heavy elements around that they started to coalesce and form rocky, hard planets. And voila, we have us. Don't say that tongue-in-cheek. That's just a 30-second accurate rundown of what the Big Bang model proposes. There is no way we can cover all of that in one session. I would refer you to this guy, Spike Theris. He was part of the military space program. He worked for the military space program. He started as an atheist, and then he finished as a Bible-believing Christian. And he published these 3 video series about astronomy. Excellent. So I definitely recommend it. But in our short time here, I want to start by zooming in on one piece of this model, looking at it so you can see for yourselves the faith that's involved. And then I want to zoom back out and look at the 2 big problems with the whole model. So let's zoom in. Are you ready? What part of this story should we zoom in on? Many to choose from. Let's start with something we're familiar with. Where did the moon come from? Now, I don't want you to think of this as a Christian right now, as a Bible believer. I want you to put on the secular glasses. Where did the moon come from? Well, you're a scientist, you start puzzling over this, you start throwing out ideas. That's what science does. Here's the first idea, the fission hypothesis. They believe that the Earth used to be this hot, molten blob, and as it was spinning, eventually it blobbed out the moon. The fission hypothesis. A couple problems. The Earth would have had to have spun 10 times faster in order to do that. That doesn't work. The orbital plane of the moon is not in line with the equator. So they kind of decided we need to scratch that idea. All right, so not to be discouraged, they went on to another idea, the double accretion hypothesis. Now, how's that for a nice $10 word? Basically, it just means 2 blobs instead of 1. They would say that there was this cloud, and the Earth and the moon both condensed separately from this cloud. A couple problems with that. Number one, if they both came from the same cloud, their composition should be nearly identical, but it's not. Okay, so once they started getting moon rocks, they realized this, got to scratch that idea. All right, then they came up with the capture hypothesis. According to the capture hypothesis, here you have the Earth, and along comes this body flying through space, and the Earth actually captures it with its gravity, and it starts orbiting around the Earth. A couple problems with this. The physics don't work out. In order to capture something like that, it's going way too fast in order to stay in orbit. And the moon shares many chemical properties of the Earth. It wasn't just a completely separate body. All right, so they had to scratch this idea. All right, not to be discouraged though, they came up with the giant impact hypothesis. Here's what the giant impact hypothesis says. A Mars-sized protoplanet crashed into Earth and broke it up, spewing stuff all over space, and some of that stuff formed into the moon. This solved a couple problems in their books, but before long, this was the most recent, This was a very popular one 10 years ago. But before long, they start finding problems with it. This is a science article. Findings cast doubt on the moon origins. Giant impact hypothesis struggles to explain similarity between Earth and moon's composition. Sure enough, without getting into details, the composition of certain elements, specifically titanium and oxygen, show that it was unlikely two separate bodies were involved. Okay, so we got to go back and scratch that off. Is there any end to this? That's the point. There is no end. There's always going to be another hypothesis out there. And sure enough, there is. The multiple impact hypothesis. You get the picture. Right? This one says the Earth just kept getting nailed by separate bodies, and they created moonlets, which eventually coalesced into the moon. The point is not, we're not going to just keep playing whack-a-mole and whacking at these different hypotheses. The point is, they're trying to explain the origin of this painting with no painter allowed. You see how that works? You could come up with a million imaginative ideas of how that painting arose, but they would all be wrong because there was a painter. This reminds me of this verse in the Bible, ever learning and never able to come to the knowledge of the truth. What's the only way you could get them to change their mind? They have to change their glasses. It's not all the hypothesis that's the problem. The problem is they're missing a hypothesis. I like to call it the giant God hypothesis. And it looks something like this. And God made two great lights, the greater light to rule the day, and the lesser light, the moon, to rule the night. But if your worldview does not allow that hypothesis, you will never come to the correct answer. So there's the zoomed in picture of the Big Bang. Let's zoom out and look at some of the two big picture problems. Two big questions for the Big Bang. Question number one. Where did the matter and the energy come from? Remember, this pew you're sitting on was somewhere in that speck. Not as a pew, but the matter was somewhere in that speck. Where did the order come from? Let's talk about these in order. Starting with the first one, where did the matter and the energy come from? So according to the Big Bang, and this strains our ability to understand what they're saying. The observable universe could have evolved from an infinitesimal region. It's then tempting to go one step further and speculate that the entire universe evolved from literally nothing. That is the belief. Evolved from literally nothing. Here's a textbook. You have to be at least this smart to write a textbook. It says, nothing really means nothing. From this state of nothingness, the universe began in a gigantic explosion. I like this article, the cover of Discover magazine. The universe burst into something from absolutely nothing, zero, nada. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. How is that possible? Ask Alan Guth. His theory of inflation helps explain everything. Now, wait a second. We're looking for a scientific explanation. And maybe something's going off in your head like, wait, isn't there a law about this? Like a law in science? Yes, you're right. A law in science simply means it's something that has always been observed to hold true. It is empirical. It's observable, testable, repeatable. And the first law of thermodynamics says matter and energy cannot be created or destroyed, only changed in form. Wait a second. You just said all of this matter was created from nothing. Well, Stephen Hawking, a theoretical physicist who is no longer alive, he recently passed. Here's what he says: at a singularity, all the laws of physics would have broken down. Even the amount of matter in the universe can be different to what it was before the Big Bang, as the law of conservation of matter will break down at the Big Bang. That's cheating. We asked for a scientific explanation, and in order to give it, they've thrown out the scientific laws. I'll tell you what that is. That is a miracle. That's what that is. All right, so let's continue though. Let's assume that nothing can explode to produce something. What gets produced? I mentioned it before. This gets produced. Hydrogen. According to the Big Bang, it all started with hydrogen. Now, hydrogen is a fun gas. Here is some homemade hydrogen I made on my stove. I'm not going to tell you how, just in case there's a pyromaniac in the audience. But you can do this at home on your stove. And then, after making the hydrogen, I tried the following. Now, full disclosure, I don't try this at home. If I had known what was about to happen, I wouldn't have been doing this standing inside my kitchen with the kids standing around. My wife was filming, so she takes part of the blame for letting me do this. Pay no attention to the kids sitting feet away. Okay, let's watch that in slow motion. Here we go again. So, needless to say, hydrogen is explosive. That's, by the way, why you shouldn't fill a dirigible with 7 million cubic feet of hydrogen gas. The Hindenburg went down, in just a matter of seconds. So according to the Big Bang, it all started with this gas, hydrogen. I want you to think about what they're saying. Hydrogen is a light, odorless gas which, given enough time, turns into people. Wow. Cool. Now, I did not say that. This is Edward Harrison. Hydrogen is a light, odorless gas which, given enough time, turns into people. So, here, really important concept here. Silly ideas explained by highly intelligent people using highly complex terms are still, okay. So, and this happens all the time. They'll throw a bunch of $10 words in there to explain how this happens, mix in a bunch of time, and voila, we have people. It's still just a silly idea. So according to the Big Bang, this entire galaxy, our sun, our moon, our earth, our mountains, our bacteria, our wildlife, and even you all came from hydrogen, which came from nothing. Where did all that matter and energy come from? Big problem. Big problem. Let's look at number 2. Where did the order come from? I'm going to do a time check. Okay. Here's what I'm talking about. Where did the order come from? Who wound the clock? Does anybody have a clock that looks like this at home? I mean one that actually looks kind of that shape. It's a prairie clock or, okay. Now, is yours running? Yes. Oh, it is? Okay. So I grew up with one of these. Hey, don't get ahead of me yet. I grew up with one of these sitting on our mantelpiece, and more often than not, when I walked into the room, it was not running. If Pastor Jones' clock is running, what can you conclude? Somebody wound it. Somebody wound it. All right, so there's another funny little law in nature called the second law of thermodynamics, and it states that total entropy or disorder of a system always increases over time. Here's what that looks like. We see it all the time. Everything tends towards disorder. That's the second law. Here's another way of saying it. Another way of stating the second law is the universe is constantly getting more disorderly. In fact, all we have to do is nothing and everything deteriorates, collapses, breaks down, wears out all by itself. And that is what the second law is all about. Here's Sue at 20. Here's Sue at 90. Here's Sue at 3,000. Total disorder. Here's your room when you wake up in the morning, right? You have to invest energy to maintain order. The same thing applies at the level of thermodynamics. Scientific American puts it this way: can science survive the death of the universe? If you are speculating about our long-term cosmic future, you must confront the second law of thermodynamics, science's most depressing insight into nature. The second law implies that the universe will inevitably lapse into heat death, in which everything, everywhere, is exactly the same temperature and nothing ever happens. Cosmologists have calculated that we will reach this cosmic dead end in 10 to the 100th, it's a long time, years. So don't lose sleep over this, all right? Eventually, the universe will wind down. This is inevitable. So, question for you. Who wound this clock? It's winding down. It must have been wound. Where did the order come from? I want to look at this order one more way. Because as we've learned more and more about the universe, we've come to realize that the universe is fine-tuned for life. Here is what the scientists have to say about it. I'm going to share a bunch of quotes from scientists. These are not Christians. These are not creationists. These are secular, well-credentialed astrophysicists or theoretical physicists. They're well-credentialed secular scientists. There's now broad agreement among physicists and cosmologists that the universe is fine-tuned for life. What do they mean by that? When I hear fine-tuned, I think of an orchestra. All right, so in an orchestra, let's say you have a violin. That violin has to be tuned just right. If it's a little too sharp or a little too flat, it's just not going to sound right, and the music won't happen. Not just that violin, but all of the instruments in that orchestra have to be tuned just right. That's what we're talking about with fine-tuning. Here's a really easy example. The planet Earth is just the right distance from the sun for life to exist. It's called the habitable zone, this green area. If it was any closer, it'd be too hot. If it was any further away, it'd be too cold. It's just like Goldilocks. Goldilocks doesn't like her porridge too hot. She doesn't like her porridge too cold. She likes it just right. Your next vacation. Which planet would you like to spend your next vacation on? These are the average annual temperatures for each of the planets. All right, there's really only one in here that looks comfortable. Okay, and that's the one we live on. So that's the idea of fine-tuning, but it's actually at a much more basic level. The laws of physics begin with a list of elementary particles like electrons, quarks, and photons, each with special properties such as mass and electric charge. These are the objects that everything else is built out of. No one knows why the list is what it is, or why the properties of these particles are exactly what they are. An infinite number of other lists are equally possible, but a universe filled with life is by no means a generic expectation. All these properties have to be just right for this pew to exist. The properties, the fundamental properties of these atoms. Max Tegmark. If the protons were 0.2% heavier, they would decay into neutrons, unable to hold onto electrons. So there would be no stable atoms around. If the proton to electron mass ratio were much smaller, there could be no stable stars. And if it were much larger, there could be no ordered structures like crystals and DNA molecules. Just right. It's shocking to find how many of the familiar constants of the universe lie within a very narrow band that makes life possible. If a single one of these accidents were altered, stars would never form, the universe would fly apart, DNA would not exist, life as we know it would be impossible, Earth would flip over or freeze, and so on. By the way, did you see his glasses? See how he called that an accident? Everyone's wearing glasses. Don't ever forget it. and Stephen Hawking, the laws of nature form a system that is extremely fine-tuned, and very little in physical law can be altered without destroying the possibility of the development of life as we know it. Last, a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. The fine-tuned universe. But wait, these guys are all secular scientists. They don't believe in God, but they recognize that the fundamental properties of the universe have to be just so for us to exist. Who made them just so? They must have an answer, right? They must wiggle out of this somehow. You want to see what their answer is? Yeah. Okay. Here it comes. The multiverse. All right. This quote is kind of lengthy and it sounds bizarre, but follow along. This is from Max Tegmark. He was one of those quotes earlier on, a well-credentialed MIT physicist. Is there another copy of you reading this article? Deciding to put it aside without finishing this sentence while you are reading on? A person living on a planet called Earth with misty mountains, fertile fields, and sprawling cities, in a solar system with 8 other planets. The life of this person has been identical to yours in every respect, until now, that is, when your decision to read on signals that your 2 lives are diverging. You probably find this idea strange and implausible. And I must confess that this is my gut reaction too. Yet it looks like we will just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a galaxy 10 to the 29th meters from here. What in the I still remember the first time I read this. I'm thinking, what in the world? What they're talking about is the multiverse. It sounds like science fiction. If Marvel does it, it's science fiction. If a physicist does it, it's good science. Yeah. What they're saying is that there's not just one universe, there's actually an infinite number of universes, and we are lucky enough to be living in the one that supports life. Here's the ultimate guide to the multiverse. That sounds useful. Here's what this article says. This is from the New Scientist. Our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing like can you supersize or not, says Raphael Busso, a theoretical physicist at the University of California, Berkeley. That's not a Christian college, by the way. Our own cosmological history, he says, tells us that it's there and we need to deal with it. Here's why they put it there. One of their main motivations is the need to explain why the physical laws underlying our universe seem so finely tuned as to allow galaxies, stars, planets, complex chemistry, life, and us to exist, rather than appealing to God or blind luck. Some argue that our existence sets parameters that reliably pluck universes like ours from the bottomless grab bag of the multiverse. Do you see the glasses that they're wearing? It reminds me of that verse, ever learning and never able to come to the knowledge of the truth, because they won't take those glasses off. These questions are big problems for the Big Bang, fundamental problems that we can all wrap our heads around. This isn't rocket science. I guess it sort of is, but it's simple. So, you're welcome to believe in cosmic evolution. But I do not have enough faith to believe in cosmic evolution. So where did all of this incredible stuff come from? Where did the fine-tuning come from? I'm so glad you asked. You see, if you turn to the very first verse of the very first chapter of the very first book of the Bible, you will find these words, in the beginning, God created. And it's just as simple as that. We are going to call it quits there. Okay, yeah, 5:55. We got 5-minute break. We're not going to be able to take questions now, but we're here for the second service. We're going to just be hanging around, so feel free to catch some questions. Next time, I'm going to skip this, sorry. Next time, we're jumping into part 3, Let There Be Life. See you next week.